Hello and good evening. This video tutorial is going to be the first of a three-part series on Layer 3 MPLS VPNs. Tonight's tutorial is going to cover basically about an hour long how to set up the MPLS core. And so if you take a look at the image that we have over here on the side, this is going to be the architecture that we're dealing with. And let's go ahead and identify right now what our MPLS core provider network is going to look like here. And so it's going to be comprised of these 5 routers. And again, this is going to be our MPLS core. And so one of the reasons to use MPLS is to sort of move away from having your core route based off of IP packets and rather route based off of labels. And so early on in your studies, you'll usually hear that MPLS is referred to as, and we'll put it down here, MPLS is usually referred to as layer 2.5 or 2.5. And the reason for that is because of the way MPLS functions. And so let me go ahead and draw, basically this would be your layer 2 header, right? And then what will happen is MPLS will add its labels in here, 1 label, 2 labels, and then you've got your IP packet header or your layer 3 header. And so the fact that MPLS sits right in here, they typically refer to it as layer 2.5. So one of the things that service providers offer is an MPLS service where you can have customers who want to connect into that MPLS service. And so we're going to have our customers will be customer A, and this is also going to be customer A's site. And we'll say that this site is in New York, and this site here will be in Santa Rosa, California. And then this will be customer B, and this will also be customer B. And these 2 customers will be located in, we'll say, San Francisco and Miami. Right? And these customers want a way to communicate with their different offices in a protected fashion and with a service level agreement. And so typically they'll go with a service provider solution where MPLS Layer 3 VPN could be offered. In addition, you may have your service provider also providing additional services to you. They could be providing SQL database services, Exchange services, things of that nature. So let's go ahead and talk about how we're going to set MPLS up here in our core. And so we're actually going to enable what's known as the link distribution or the label distribution protocol, LDP, right? And we're going to enable it on every interface where we want to run MPLS, right? And so we're going to go ahead and run LDP on all of these interfaces that are part of the provider core. You'll notice that we did not highlight any of the interfaces out here as green because these interfaces are the ones that the customer will be connecting to, and unfortunately the customer connections will not be connecting directly into MPLS or participating in the MPLS. Will actually be creating VRFs or virtual routing and forwarding instances on the PE routers. And so let's talk about that for a second. So router 9 is a PE router, so it's known as the provider edge because it sits at the edge of the MPLS cloud. You also have what are known as P routers, which are simply provider routers that are not at the edge, that sit in the middle of the network, that have no customer connectivity. And so then router 5 would also be a PE router. And so the provider edge routers, these are the routers where the majority of your configuration comes into play when configuring routing between customer sites. And so the sort of final cog is you've got your VRFs on either side, and what we're going to do is we're going to create between the provider edge routers, right, across this MPLS cloud, we're going to create a multi-protocol IBGP, and that was not a good B there, IBGP peering, right, between router 9 and router 5. And so real quickly here, we're going to carve this guy up also into VRFs, right? And so that's how we are going to logically carve these routers up. So like, let's say there was a third customer who wanted to connect in. We would just create a VRF for him, and then a fourth customer comes along and we would create another VRF for him. And you could do the same thing over here. And so this is how the service provider can take a single physical router and then carve it up into logical units so that you can have additional customers connecting to that router. Okay, so we've got our OSPF core laid out here. So this is going to be our OSPF MPLS core. We're going to have a multi-protocol IBGP peering between the two provider edge routers. We're going to create some VRFs. And so in this video, we're going to get the core configured and the VRFs configured, and then I'm going to go ahead and take a break. It'll be a good stopping point right there to then come back and do part 2 of the video, which is going to show us using BGP as the PE to CE routing protocol here, and we're also going to use BGP as the PE to CE here. And this conversation will be very short because when you're using BGP as the PE to CE, it's very, very straightforward, very simple. We're going to make it more complex when we do OSPF down here for customer B. And so ultimately we'll have OSPF set up for customer B, and that will also go through the MPLS cloud. All right, so let's go ahead and get started. Again, we're starting from scratch. So all of the hardware that we have is completely unconfigured. So we will start on router 5. So the first thing we'll do is go from privilege exec, or from user exec to privilege exec, and then in the global config. And I'm going to configure interface loopback 0 to begin. So we'll just say IP address, and all of our loopbacks are going to mirror the router number. So we'll make it router 5. And we're going to be using these loopbacks as the LDP router IDs. We're going to be using them as the OSPF router IDs, and in BGP as well as the update source. So we're going to go ahead and make all of these /32s. And I'm actually going to misconfigure, I'll misconfigure router 7 so that you can see what happens when you set it up as a /24. And again, there's a common misconception that you cannot have your loopback cannot be a /24 or something other than a /32. And so you can do that, and we'll talk about that when we get these set up. We'll be able to see that it's not going to be issued a label, an LDP label, and I'll show you how to fix that as well. So, all right, so we've got the address configured here on the loopback interface, and so there's some common things that I like to do when setting up my my MPLS, right? And so the first thing I'd like to do after I get the loopback interface up is to go ahead and hard code, right, the MPLS label protocol to be LDP. Now, by default, it's LDP, and I believe it shows you here. When you do the question mark, you can see that it says it's the default. I like to make sure that the label protocol is LDP. I also like to set the router ID, the MPLS, oops. So MPLS router ID, LDP router ID, and I like to set that to the loopback interface that we just configured, the 5.5.5.5. MPLS will not work if Ceph is not enabled, and so even though it's on some of the later platforms, it's on by default, some of them won't let you turn it off. So I'm going to go ahead and leave that set up the way it is. And then the MPLS Ldp label range, and maybe I think it's MPLS, is it label range? Yeah, label range. There we go. And so typically you can use between 16 and a million and what is that? 48,575. So it's a 20-bit construct, right? The MPLS label. So if I come back over here, the labels that we looked at, so if I were to take label 2 over here, and we'll say this is label 2, and break it out, what it looks like, right? Whoops, is you've got 20 bits at the front, and this is the actual label number, right? And so that's that number that you see here, this 16 to 1,048,575. And so these are unique to each of the routers. So each router has this same 20-bit range. So we'll just say 1,000,000, right? So each router has 1,000,000 labels that it can use. So the next thing that we're going to take a look at is going to be the second field, which is the experimental bits, the EXPs, and this is usually for if you're doing MPLS traffic engineering or any kind of QoS as well, is that you would use the experimental bits. And so that field is 3 bits total, right? So we'll say this is 3. The next field is the bottom of stack label, or it's referred to as the S bit, and that is 1 bit. And then you've got the TTL at the end here, and this is 8 bits, right? And so the reason that the range you see here is from 16 to 1,048,000 is because it's 20 bits. Now the first 16, right? So 0 through 16, those are reserved. RSVD, let's put RSVD. So those are reserved, 0 through 16. And they're actually used in some cases, and actually used in many cases in the MPLS setup. However, when you're actually just letting it create the labels by default, letting the routers create the labels by default, it's going to go ahead and start at 16. So what we're going to do is we want to make sure that we have our label ranges configured so that they're kind of meaningful when we're looking at some of the output. It's going to make some sense, and it's not going to be just sort of a random, random stack of numbers starting from 16 and going up. So I like to say, so on router 5, we'll say label range is 500 to 599, right? Okay, so the next thing we're going to do is I'll go ahead and I'll set up the OSPF. So router OSPF 1, we're going to set the router ID to the loopback address of 5.5.5.5. I want to log any adjacency changes, and this is another thing that I like to do is the MPLS was Ldp, and is it IGP? Oops, MPLS Ldp Sync, right? And so what does the MPLS Ldp Sync do? So what it does is it keeps the label distribution protocol in sync with the IGP, the Interior Gateway Protocol, in our case OSPF, on each of the interfaces where LDP and the IGP are running, right? And so what can this prevent? Maybe there's an LDP issue on an interface and LDP goes down. It's possible that the IGP isn't going to pick that up and is going to continue to forward labeled traffic via that path. So we want to make sure that LDP is in sync with the IGP on each of the interfaces. And you can actually disable this on any interfaces under the interface configuration submode that you didn't want to have MPLS Ldp Sync running on, right? So I turn it on globally here, and let's go ahead now and jump into interface E10. So I'll say interface E10, no shut, and we'll say IP address is going to be on the inside of our MPLS core 172.16.56.5. And we're going to make these all /24s. IP OSPF1 area 0. And then we're going to go into and actually, so what I'll do is now I'm going to go ahead and on router 5 and 9, I'm actually going to go ahead and run the MPLS IP command on the interface. We're going to show you the other way to set it up as well under the router OSPF1 configuration mode, under the process ID, the global router config mode, if you will, for OSPF. And we're going to set that up there for routers 6, 7, and 8. So here I'll just do MPLS IP. We'll say interface E11. We'll say no shut. And I'm going to say IP address 172.16. What is that going to be? 58.5. And again, /24. MPLS IP. And that interface is up right now. So we've now got the interfaces configured on router 5. We've got the IP set up, and we have MPLS or LDP. The LDP protocol is going to be running on those two interfaces. So I like to go ahead. We'll do a couple of debugs here, and actually let me get the router name. We'll say this is going to be provider edge 1 router 5. Okay, and so I'm going to do some debugs here. So I'm going to debug MPLS Ldp, and we want to get messages, and then we also want to get, that's right, sent and received, so sent and received, and we also want to get debug MPLS Ldp session. And actually it's not session, I'm trying to remember, there's one that I usually run. Is it transport? Might be transport events. Yeah, transport events. There we go. Okay, so as you can see, what's happening right now is since we've enabled LDP on the interface, on the two interfaces, it's actually sending hellos out. And so the hellos are multicast packets that get sent out to the all routers multicast address of 224.0.0.2. And so I'm going to say you all here to stop it for a quick second. And so let's go ahead and take a look at the debug output. So as you can see here, we've got the send LDP hello. It's going to be sent out Ethernet 1.1, and here is the destination address, right? So this is a multicast packet, and it's going to be going to UDP port 646, right? So it's UDP port 646, and it's basically just getting sent out, and router 5 is looking for someone else who is running LDP on the same segment to establish, start up a TCP session with to run LDP, right? So again, you can see it's doing Ethernet interface 1.0 as well as 1.1. And how often is it sending the packets here? I believe it's every 5 seconds. So let's see, Ethernet 1.1 was 5548, and then 00039. So every 5 seconds, a hello packet is getting sent on each of the interfaces trying to find an LDP neighbor. All right, so let's go ahead and clean that up there, and we're going to go ahead and configure router 6 right now. So first thing we'll do is we'll get the host name in here, so we'll just say R6, and again, the same set of things that I had previously done, I'm going to actually do those exact same things again, right? So we're going to say MPLS label protocol is going to be LDP. We're going to go ahead and set the MPLS, actually let me get that interface loopback 0 IP in here, IP address 6666, make it a /32, and let's get back to MPLS Ldp router ID is going to be loopback 0. We're going to say IPsef. We're going to say MPLS or actually label range. Is that right? There we go. 600 to 699. And so we're good there. Let's go ahead and get the OSPF process set up. So router OSPF1, the router ID will be 6.6.6.6. We're going to log adjacency changes, and then again we're going to go ahead and set up the MPLS Ldp Sync, right? So we'll set up the sync, and then we'll go under, and actually for router 6, so here's the second way that you can set up LDP on the interfaces. So I can say MPLS Ldp auto config area 0. And so what is this command going to do? So MPLS Ldp auto config is going to enable LDP, but it's going to enable it on every interface that's running in area 0. So as soon as I hit enter here, and let me go ahead and turn on these debugs again. So we want to see the transport events, and we want to see messages received and messages sent. So we're going to see quite a bit of activity here as soon as we kick on MPLS Ldp autoconfig, or actually we should jump into the interfaces first. So let me get these interfaces up. So interface E10, we'll say IP address is going to be 172.16.56.6. And we're going to say IP OSPF 1 area 0. So as soon as I put that command on, this interface is now running in area 0. And so do I have connectivity over to 172.16.56.5? And I believe I forgot to type no shut. So let's say no shut. And now let's run that ping command. We may actually get, yep, there we go. And as you can see, even before we did that, the interface state changed to up, right? And we've gotten our pings through. And so we're also going to see any second now, we've got the OSPF adjacency now has been formed between router 5 and router 6. And the final thing that we should see is we should see an LDP session establishment between router 5 and router 6. And so if I were to type in do show MPLS Ldp neighbors, we don't have any neighbors right now. So that what that tells us is that while we saw LDP running over on router 5, on router 6's E10 interface, it's not running yet. And so let me try to give it a little bump here. So I'll give it a kick. And so I'm going to say do clear IP OSPF proc, since we've got it set under the process for OSPF, and let's see if that does it. So it brings up the OSPF adjacency has gone from loading to full. So if I do a do show IP OSPF, you can see that we've got a neighbor adjacency with router 5, OSPF neighbors, and so we're good there. And so let's see if we have do show MPLS Ldp neighbors. So we still have no neighbors. So let's check this out. Let me do a do show run section OSPF. And the MPLS Ldp auto config is there. We've got the router ID set. Do show run include ID. All right, the loopback interface is up. Can I ping? Whoops, 5.5.5.5. Aha, so I can't ping the loopback addresses. So the reason for that is obviously because the loopback addresses were not put into the OSPF area 0. So let's get those guys added in. So IP OSPF 1 area 0. And now I'm going to put it in on router 5 as well. So we're going to say interface loopback 0 IP OSPF, oh whoops, go to global config. So interface loopback 0 IP OSPF 1 area 0. And now we're going to get our LDP session established. And so I'll say do you all, because we've got the debug output we were looking for. So as you can see right here, sending and receiving the LDP hellos, right? And it's got an incoming LDP connection from 5.5, or so I should say between 5 and 6, and you can see here that it's going to port 646. So the incoming LDP connection on router 5 was coming in from router 6. So we'll say that router 5 in this case is the TCP server, and the client is router 6, because the client connection is initiated out of a random high port on router 6 coming into the well-known port 646 on router 5. You can also see that they exchange their label mappings. And this is important because one of the things that LDP will do is it's actually going to communicate all of the labels from all of the servers that are in the MPLS core to each of the other servers, or each of the other routers, so that they'll know whose labels go with which routes that they see in the MPLS core. So now if I do a do show MPLS Ldp neighbor, you can see that we've got some output here showing that router 6 is the LDP neighbor right now. If I were to do a do show MPLS interface, another command, it'll actually show me that we've got MPLS running, right? And we're actually using LDP, okay? And we're operational, and these are the interfaces on which LDP is running, right? Okay. So we've got router 6 configured. Let's go ahead and hop over to router 7 and get the core completed here. And so on router 7, we were going to go ahead and leave the loopback address as a /24 to see what happens. So we've got the host name configured. We'll say interface loopback 0, IP address 7.7.7.7, and we're going to say we're going to leave it as a /24. And so this is going to break the MPLS label for this route, right? Because it's not that it has to be a /32, it's that by default OSPF, irrespective of how we set this route up, right? Or I should say irrespective of the fact that we set it up as a /24, OSPF says, I don't care, I'm going to advertise this as a /32. And so we'll take a look and see what that looks like. So let me say IP OSPF1 area 0. We'll get the loop back into area 0, and then we're going to go ahead and do the actually the sort of the basic configuration tasks, and we're going to go ahead and set the protocol to MPLS label protocol LDP. We'll set the MPLS Ldp router ID. Whoops, MPLS Ldp router ID to loopback 0. MPLS label range on 7 is going to be from 700 to 799 IPsef. And then let's go ahead now and go into the router OSPF1. We're going to log any adjacency changes. The router ID is going to be 7.7.7.7. And we want to do the MPLS Ldp Sync, right? And since we're on router 7, we're also doing the MPLS Ldp auto config, because again, all of the interfaces on router 7 are going to be running LDP, right? So if I were to say do show run section OSPF, here's our OSPF config right now. It's MPLS Ldp Sync, MPLS Ldp auto config, router ID 7777. So now let's go ahead and configure some of these interfaces here. So interface Ethernet 02, we'll say no shut, IP OSPF1 area 0, and we got to get the IP address on here first. So 172.16.76.7, and now we can say IP OSPF1 area 0, and this is going to form an adjacency, and it should also form an LDP TCP session with router 6. However, let's see what happens since we've misconfigured the oh, and I actually have that backwards. I apologize. IP address, the IP, the third octet, 72.16.67.7. And I should be able to ping now 172.16.67.6. And did we do the no shut? I'm pretty sure we did the no shut on this interface. Let me check back here. Do show IP interface brief. Did we configure that one? We actually did not on router 6. So let's go back to router 6 and we'll say interface E0/2, no shut, IP address 172.16.67.6, and IP OSPF1 area 0. We're going to go into interface E01. Whoops, interface E01. Say no shut, and IP address 172.16, and this is going to be 69.6. IP OSPF1 area 0. Okay, so now if we come back over here to router 7, we should have a little more success there. If I do a do show MPLS Ldp neighbors, you can see that we don't have any LDP neighbors right now. If I do a do show MPLS interface, you can see that we have it turned on interface, and there we go. The OSPF adjacency with router 6 just went from loading to full, and there's our LDP session. So now when I do the LDP neighbors, you can see that we actually have a session established with router 6. So if I do a do show IP route at this time, you can see that we've got a directly connected route that we've configured as a /24. Okay, so if I were to go over to router 6 and say do show IP route OSPF, what do we see? We see that OSPF is advertising it as a /32. Even though we configured it as a /24, OSPF says, I don't care. So that, I mean, the problem is, at the end of the day, the problem is that OSPF, irrespective of what we configure the mask to be, is by default going to advertise this loopback as a /32. And so the problem is, it's not that you cannot have, let me rephrase that. So it's not that you have to have a /32, it's that they have to match. Whatever OSPF is advertising and the mask that's actually configured on the interface, those need to match. And so we'll leave it like this for now to leave it broken, because there's some labeling challenges that I want to show you where it'll say no label. So it won't actually assign a label to 7.7.7.7. So, okay, so we'll leave that the way it is. We've got router 6 all configured up. Let's configure the other end of router 7, which is going to be interface E01. Say no shut IP address 172.16, and this is going to be 78.7. Whoops. IP OSPF1 area 0. And we did do show run section OSPF. So we have the MPLS Ldp auto config there. So we're good there. Let's drop down to router 8. Go to user exec to privilege exec into global config. We'll set the host name as router 8. Get the loopback address configured. IP address 8.8.8.8. So we'll make that a /32. And then we're going to exit out. We're going to say MPLS label protocol is going to be LDP. MPLS label range on router 8 will be 800 to 899. MPLS Ldp router ID is going to be loopback 0. We want to make sure Ceph is on at all times. And let's go ahead now and go into router OSPF 1. And we want to log adjacency changes. And we're going to set up MPLS Ldp Sync. And then we want to get the router ID set to the all 8s. Right? And now let's jump into our interfaces here. So we're going to say, and actually let me go back into interface loopback 0. I don't think I did the IP OSPF 1 area 0. So let's go into interface E11, which is going to, actually before we do that, let me step back to router OSPF 1. We want to make sure we get the MPLS Ldp auto config here, because router 8, again, all interfaces are going to be running MPLS, so we'll set it here in area 0. All right, so I'll go to interface E11, and we'll say no shut. IP address is going to be 172.16.58.8. IP OSPF 1 area 0. And then we're going to go to interface E01. We're going to no shut. IP address 172.16.78.8. And that's going to be /24 IP OSPF 1 area 0. And last but not least, Ethernet 00, no shut. IP ospf1, oops, make sure I get the IP address on here, 172.16.89.8, IP ospf1 area 0. All right, so we have all of our interfaces configured here on router 8. Let's do a do show MPLS interface. So again, you can see we have MPLS running on all of our interfaces. If I do a do show MPLS Ldp neighbor, we don't have any neighbors right now. And so what's the reason for that? So if I do a do show run section ospf, you can see we've got the MPLS Ldp auto config set. Aha, so there we go. We're just waiting for ospf to kick in. And those are the hardest problems to troubleshoot, are the ones that aren't actually problems. So as you can see, it was just being impatient, and then it actually came up. So there, our LDP neighbor relationship is up with 7. It's also up with 5 if I do a do show IP ospf, right? You can see we've got our ospf information. If I do a do show IP or a do show IP route ospf, we still see that /24 loopback address is still being advertised as a /32 in ospf, right? So if I do a do show MPLS Ldp Bindings, so this is some interesting output to take a look at right now, because this is basically the equivalent when you're talking about the when you're talking about Ceph, right? And you have the FIB, the forwarding information base, which gives you your adjacency information, your next hop, layer 2 to layer, or layer 3 to layer 2 adjacency information. So this would be the equivalent of the label information. This is called the label information base, the lib, right? And so this is equivalent to, and that is a terrible arrow, so this is equivalent to the routing information base, or the rib, right? So the lib is the label information base, and we should have a one-for-one mapping of lib entries to routes, right? So if we look here, we can see that for 5555/32, we've got label 802, right? And so we're on router 8. So the local binding would be 802. On the outbound, if it's going to router 7, it's going to have label 701 pushed onto the label stack, and then it gets sent to router 7. However, if it's going to router 5, you can see that it's implicit null. And so what does implicit null mean? Well, implicit null is synonymous with penultimate hop popping. And so this signals MPLS to pop the last label off the stack and send the traffic, and in our case here it would be from router 8 up to, whoops, I'm sorry, going the wrong way, from router 8 over here to router 5, and it doesn't need to have a label on it. You can go ahead and pop that label, right? And so the same thing here, if traffic is getting sent to 6666, right, the local binding is 801 for that route, and we would push label 700 on there if we're going to router 7, or we would push 500 on there if we're going to router 5, right? And so you can see we have a label for every route, even for the transit networks. We've got the routes set up here as well. And again, you can see the implicit null. And so a real quick note, so the implicit null, I shouldn't say the opposite, but there's also an explicit null that's outside the scope of what we're talking about here, and that's typically what you'll see in the service provider space when you're using QoS, right? Or you're using those experimental bits, right? These guys right, where are they at? The experimental bits right here, right, for QoS. And what happens is, and so remember we had said that 0 through 16 are reserved, right? So those label numbers are reserved, and the reason they're reserved, and this is a case where they are reserved, so that's 0, right? When you're talking about the explicit null, what it does is it sets the label ID to 0. And so it's going to use this reserved 0. And what that tells MPLS is you go ahead and set the label to 0. That way the last hop router, this signals the last hop router to preserve the QoS settings that are coming through with the experimental bits, right? And so that's kind of, you've got the implicit null, but then there's an explicit null as well. So make sure you're aware of that. And so again, the label information base, and that's what we see when we run this command here, do show MPLS Ldp Bindings, is equivalent to the rib. So if I were to look here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 entries. So let me go ahead and clear the screen here, and let's do show IP route, and let's see how many routes we've got. So we've got the OSPF route, right? So we've got 1, 2, 3. You've got your directly connected with the 8888, so we'll say 4, 5, 6. We don't count the local. 7, 8, and 9. Right? So it matched up 1 for 1, right? So the locals, we don't have labels for the locals over there, but we do have them for the transit segments, right? Okay, so they did match up 1 for 1, right? And so the lib, again, is equivalent to the rib, or the routing table. All right. So let's go ahead now, and on router 9, which is going to be PE2 in our case here, we're going to say, and what did we do with R5? Did we call it, so PE1 R5, so we're going to call this PE2 R9, right? So again, some house cleaning, we'll say MPLS Ldp protocol, or I'm sorry, MPLS protocol, I'm drawing a blank, MPLS label protocol Ldp. Sorry about that. MPLS label range is going to be 900 to 999. And we're also going to say MPLS Ldp router ID is going to be loopback 0. Make sure Ceph is always on. And then we'll get that loopback interface configured. So we're going to say IP address 9.9.9.9. Make sure it's a /32, IP OSPF1 area 0. And then we're going to go ahead and go into router OSPF1. We're going to say router ID 9.9.9.9. Log any adjacency changes. And whoops, sorry about that. We'll say MPLS Ldp Sync. And we're going to say, actually, we need to go under the interfaces to turn on the MPLS process. So we'll do that when we get under the interfaces. So we'll say interface E01, no shut, IP address 172.16.69.9, and IP OSPF1 area 0, and MPLS IP, right? Okay, and then we're going to say interface E00, and that's going to be no shut, and IP address is going to be 172.16.89.9/24, and IP OSPF1 area 0, and MPLS IP. So again, the MPLS IP command, we ran that on routers 5 and 9, our 2 provider edge routers, because we wanted to control specifically which interfaces this is going to run on. And then again, just showed you a different way to do it, which is the MPLS Ldp auto config under the global router OSPF process, configuration process, to get it set up. And so there you go. Our neighbor adjacency with router 6 is now from loading to full. We should see shortly here, and there it is. The Ldp neighbor session has been established via TCP, right? So it's a TCP session that gets established. And again, if I were to do show MPLS Ldp or MPLS neighbors, do show MPLS Ldp neighbors, right? You can see again that router 6 here is the server, router 9 is the client, because it's coming into the well-known port 646, TCP port 646, and it's also on the UDP side, the hello packets are going out to port 646. So let's go ahead now, let's take a quick inventory here. Let's do show IP route OSPF, and let's level set and see where we're at. So 9 sees the routes for 5, 6, 7, and 8. So that's good news. It sees them all as /32s, right? Even router 7 is seen as a /32. So if I type do show MPLS forwarding table, we're going to see that we've got a listing here of local labels, and those are the labels that would be imposed for router 9, right? So label 900, if it would be a local label, would get popped if it was going over to router 8, right? And that's the outgoing label. And so if we had, again, if we had a packet that was going to 7777, we've got two equal cost paths right now. The first one would, if it was going to router 6, would have 601, the label 601, pushed onto the label stack. If it was going to router 8, it would have label 800 pushed onto the label stack. Again, if it was something was going to router 6 or going to 6666, right, it would pop the label, because when it gets to router 6, that's where the traffic is destined. So this is that penultimate hop popping. So we're going to pop the label off on the penultimate hop, which is the next to last hop. In this case would be router 9. However, if router 9 was going over to router 5, it would push label 600 on it, right, and send it out to router 6. And then you can see here for these segments, it's saying that it would pop the labels because these are going to be connected to the next hops. All right. So if I were to do show MPLS Ldp Bindings, so you can see the binding table's gotten a little larger because we've got some more routes in here. And so what I'm looking for specifically, you can see we have the label information base entry for 7777/32. It shows that the local binding is 901, right? So if I were to come all the way over here to router, actually let's go to, to router 5 and say show MPLS Ldp Bindings. If we were to take a look here, you'll see that the label distribution protocol has sort of communicated the labels that need to be placed onto the packets when they're being sent across the MPLS core, right? So if 5 is sending something to router 8, it's going to push label 603 onto it if it's trying to get here, if it's going over toward router 6, right? So, all right, so we've got the labels taken care of, and we still have that /24 on router 7. And so let's come back over here to router 7 and say show MPLS Ldp forwarding table, show MPLS forwarding table, sorry about that. All right, and so you can see we've got all of our entries here, but you'll notice, what do we not have an entry for? So there's no entry for 7777. What if we were to run that same command, MPLS forwarding table, over here on router 8? Same thing. You don't see the loop back in here, but we do see no label, right? And so this is what I was talking about early on. If you see no label is bad. And this means that something is wrong, right? Now, it's interesting. You'll see here that it shows that the prefix of the tunnel ID is a /32. And again, that's because this is how OSPF sends that information out. So we misconfigured it. Let's go ahead and fix it right now. So if I go over to router 7 and I go into global config and I say interface loopback 0, IP address 7777, 255, 255, 255, 255, and I hit enter, what we should see is the LDP relationships are going to go down and they're going to come back up. So when I drop back over here to router 8 and I rerun that command, what does it say now? So before it said no label, now it says pop label. Because again, remember, no label is bad. So now what I'm going to do is I'm actually going to go ahead and I'm going to make it a /24, and we're going to make it work. as a /24, and I'll show you how to do that. Because again, there's a big misconception out there that it has to be a /32, and it does not. It doesn't have to be a /32. So let's break it, right? So I'm going to go ahead and say IP address 7777, make it a /24. So we're going to have the same downing and then reestablishment of the LDP neighbors. If I come back over to router 8, let's take a look. Now it's back to no label. So how do I fix this, right? If I really wanted it to be a /24 for whatever the reason was, whatever my use case may be, what I can do is I can simply say IP OSPF network type and change the network type to point. Now, this is actually going to have some other ramifications if you're doing the CCIE lab and you've already got everything set up and everything configured. Then this might not be something you want to do if you're going to go back and change your OSPF network type. So I'll change mine to point, and now let's see what it says. So it still says no label. If I'm on router 8 and I go into interface, I apologize. If I go into let's do a do clear IP OSPF proc, and I say yes. So the neighbor relationship should go down. And we still have that no label in there, right? So let's take a look now and see if I were to do show IP route OSPF. And we'll come over to router 8 and do show IP route OSPF. Whoops. Forgot to turn off the domain lookup there. So we'll give it a second, let it finish out here. All right, so there we go. So do show IP route OSPF. Right, and so you can see that it's actually advertising now as a /24 and not as a /32. And let's confirm do show run interface loopback 0 that it has been set to IP OSPF network point. And let me see here, because we should be seeing do show MPLS Ldp or MPLS forwarding table. Yeah, and it still shows that it has no label. All right, so we should be seeing a label here because they actually match, and the prefix of the tunnel ID. So I may have to come back and actually take a look at this. So we broke it, it was broken, we fixed it, we broke it, but now it's still broken. And actually changing the changing it from a /32 to a /24 and flipping it to point should solve the issue. Let's do a do show IP or do show MPLS Ldp Bindings. And let's see here. So the binding, so it still has the entry. You can see it says no route, right? So because there is no route for 7777/32, but there is a route here, right? And let me make sure I didn't just look past if it was further down. Oh, I apologize. Yeah, there we go. All right, so it is in here as a /24. It's at the bottom. So we still kind of have this entry here, sort of this bogus entry to 7777 with no route. However, it did fix the issue. So as you can see, again, the loopback doesn't have to be a /32 as long as you change the IP OSPF network to point, right? And this is correct, right? It's going to pop that label. So let me go ahead and we'll flip it back. Now that we've seen the ways to break it, let's go ahead and fix it. Interface, and let me make sure I don't do this on the wrong router. So we'll come back over here to router 7 and I'll say interface loopback 0, which is where I think we're at. Say no IP OSPF network type point. Whoops. All right, so do show run interface loopback 0. All right, so now it's back to a /32. Let's come over here and let me make sure I set the IP address to 7777. And we've got our /32 back. So let's pop over to router 8, and we're going to say wait for the connection and the LDP session to reestablish and come back up. I'll say do show MPLS forwarding table. All right, so now we've got anything headed to this less specific route, right? The 7770/24. The label, right? We're set back up here. It does not say no label. Now it says pop label, and we've got it in here as a /32, right? So we're good to go there. So we've seen that it does not need to be a /32. You can use a /24. Okay, so one of the next things we're going to do, and probably close to one of the last things before we do the VRFs, is on router. We'll come over to router 5 here. And when we were doing the debugs, you can see the hello messages going back and forth. So one of the things that they may break on you in the lab would be to basically say LDP is not running between routers 5 and router 6, troubleshoot and figure out why. Or MPLS is not functioning properly between router 5 and router 6 and resolve the issue. So you can run into issues where, remember we had said that the hello packets are going out UDP port 646. So if I were to configure an access list to say IP access list extended 100 and deny, let's see, we'll just say deny UDP any equal to 646, right? And then permit IP any. And so if I were to go on to interface E10 and say IP access group 101 in, let's see what happens when the hello packets are actually being blocked. And so we should see something here shortly that's going to show us that we've got a block. Do show IP access list. Whoops. And so there we're basically denying UDP to anyone from anyone equal to port 646, and then we're permitting everything else. And now that I think about it, do show MPLS neighbor, do show MPLS Ldp neighbor. Oops. And let me make sure we've got that. Do show MPLS. And did I leave off? No, we've got it inbound 646. Let me make sure I've got this right here. So 646, it's coming from 625. And that's the TCP session. Let me change this. Let me say no. Let's set it outbound as well to make sure that we're blocking 646. So if I were to do a do show MPLS Ldp, or do show MPLS interfaces. So we're on 10 interface, do show run Ethernet 10, show run interface Ethernet 10. Oh, and I know exactly what the problem is. So I used access list 100, so no IP access group 101 in, no IP access group 101 out. Yeah, because it should have taken much quicker. Okay, so we're going to say IP access group 100 in, and that should be good enough. And in the next 5 seconds here, depending on where the hellos are at, what stage, what stage they're in, they go every 5 seconds. We should see here shortly, and there it is. Okay, thank you. Glad that this worked out. Get the right access list number in there. So what will happen is you may have an access list applied to an interface that's blocking UDP port 646. And so now when I say do show MPLS interfaces, you can see that it's kind of misleading. So if you were to start your troubleshooting here, you might look at this and think, hey, these interfaces are up, everything is okay, they're operational, so it can't be something about the interface. And even if I did a do show MPLS forwarding table, right, you still see the entire forwarding table. In fact, one of the things that we see, though, that we did not see before that should be an immediate clue that everything is broken or that something is broken is right here. Remember I said no label is bad, right? So that is bad because we have no labels being put on any of the routes. And when we looked at that before, it actually gave us the outgoing label numbers in some cases. In some cases it said pop the label. So that's definitely something that you should clue in on right away to then go ahead and say, okay, well, it's clear that LDP is probably not running on all of the interfaces. So let's talk about some other commands that you can use to troubleshoot. If I do a do show adjacency, right? So this shows me the adjacency out 1.0, right? Ethernet 1.0 out to 56.6. If I were to type in here do show IP or adjacency detail, actually, I can do show adjacency detail, and that's going to give me some additional information, right? And it's actually going to show you the enumeration of the MAC address, how it's mapped, and the MAC address for the port is right in here somewhere. So if I were to do a do show interface E10, you'll see the burned-in MAC is AABBCC000501, and where are we at? AABBCC000501, right? And so this shows you the adjacencies that you have established and the mappings for the layer 2 to the layer 3, how to get to that next hop, right? Some other commands that I like to run, do show MPLS. Let's see, we did interface, we did LDP neighbors, bindings, forwarding table. You could do MPLS IP binding for a specific route. So if I were to say 9.9.9.9/32, let me come all the way back here and we should set this to do. And so there you go. And this is a nice command because this command from router 5's perspective is going to tell me that the outbound label that's going to get put on this on the label stack to get to router 9's loopback address is going to be 806, and it's going to get sent out to the next hop, which is going to be 8.8.8.8, or actually over to router 8, I should say. So, and another really good command is do show IPsef exact route. And if I were to say from 5.5.5.5 to 9.9.9.9, what I like about this command is this command spells out for you exactly where the packet's going to go. And you'll notice that we're going out to router 8 because right now, right, routers, the LDP relationship between 5 and 6 is down. So we have taken, effectively, we've basically taken that link down, and so now all the traffic from 5 to 9 is going to come only this way, right? And so that's what we're seeing here. And so what this is saying is from router 5 to router 9, I'm going to go out Ethernet 1.0. But what is it missing? Right? It's missing the tag, right? It's not telling us what the tag is, although it's saying the adjacency is out Ethernet 1.0. It's not giving us the tag information that we actually do see up here, telling us the outbound label will be 806. And so if I step over to router 8 and do a do show or do a do show MPLS forwarding table. So what happens if something comes into router 8 with label 806, which over here on router 5, what did we just see? If 5 is trying to get to 9, right, the label will be 806. So when that comes into router 8, router 8's going to say, that's a local label for me. That's my inbound labels, 806, that's me. What do? I pop that label, because it's going to 9999/32, meaning that next hop out that interface, right, the E00 interface to this next hop IP, router 9, it does not need to have a label. So we're going to pop the label off of there, right? So let's draw that out real quick. And first, actually, let me pull this access list off of that interface, and let's bring that back up. So now that it's off, the hellos are still going, right? The access list was filtering them out, and there you go. So within about 5 seconds, we've got LDP hellos going multicast to 224.0.0.2. So we've picked it up. Now we've reestablished our LDP adjacency with between routers 5 and 6. So if I do show MPLS forwarding table now, you can see that everything looks much healthier. If I do show MPLS interface, right, we see both of the interfaces, but remember, the big difference that we see here is now the outgoing labels are actually fully populated, where before everything in here said no label, right? Okay, so we actually have our labels on here. So let's kind of trace the path, right? So if I was trying to go to 9999, it looks like the next label that I'm going to put on here is, let me change my color here. We'll go to, I haven't used green yet, right? So, or I used it for the port. So if I'm going from 5 to 9, it's going to go this way. I'm going to push label 606 onto the label stack. And then that's going to come in here to router 6. So if we step over to router 6 and I say show MPLS forwarding table, we see that if it comes in with label 606, what are we going to do? Router 6 says, I'm going to go ahead and I'm going to pop the 606 label off, right? So 606 is going to get popped off, and I'm going to forward that packet to the next hop out 172.16.69.9, right? So that's basically what the labels are doing, right? You're pushing the labels onto the stack, or onto the label stack, and you're popping the labels off the label stack as it travels through the MPLS core. Okay, so we've talked about the /32 for the loopback addresses, and that it can be a /24. You just need to change the IP OSPF network type. We've talked about MPLS being set up, some things to troubleshoot for. Look for access lists that are blocking 646. And one other important one, remember I had said that, and we'll do this on router, well actually we're not going to wait for that, so we'll do it on router 5. So remember I had said that when we talked about the MPLS label protocol, where you can have LDP as the default, but you'll notice that TDP is still a choice, and TDP is the old Cisco tag distribution protocol, because this used to be called tag switching back in the day. And so it's important to note that you can run LDP and TDP at the same time. However, they are not interoperable. So again, I could be running LDP and TDP all throughout this environment at the same time, but LDP is not communicating with TDP. So, and that's commonly referred to as ships in the night, where they're basically, going back and forth across the network, but they're never communicating with each other. And so I'm going to prove that right now by saying TDP. So I've just changed the label distribution protocol on router 5 to TDP, and you'll notice immediately the LDP neighbor relationships here with router 6 and router 8 are done. So if I were to say do show MPLS interface, you can see that it shows my interfaces are operational. However, this should be my clue right here that we're going to have a problem, because TDP will not work on the interface. So again, TDP and LDP can be running at the same time, but they're not used to communicate with each other. They're not used to establish adjacencies. So I can't have TDP on one side and LDP on the other side and expect that I'm going to the label distribution protocol and TDP, the tag distribution protocol, are going to come up and be able to sort things out. One of the biggest things is they use different ports, and I can't remember actually if it's 711 for TDP or not, but it's not 646. I know that. So again, keep your eyes peeled for that as well. So let me turn this back. I'll say, whoops, we'll say no MPLS Ldp label protocol, MPLS label protocol Ldp. Even though it's a default, I like to hard code it in there. And one other thing, remember we set the synchronization up on the interfaces. So if I were to say do show, and let me make sure I get this right, Ldp, is it IGP? Let me get out of here so that I can do a show MPLS IGP, maybe it's Ldp IGP Sync. Yeah, there we go. All right. So you can see on Ethernet 1.0, Ldp is configured and synchronization is enabled. And it gives us a sync status here. On Ethernet 1.1, it's not. So let's take a look at that real quick. So if I were to say show run section OSPF, we have MPLS Ldp synced set up. However, it's not on interface 1.1. And I think there were I was seeing some odd behavior there with 1.1. Let's do a do show run interface E11. Oops, show run interface E11. And I see the problem. Do you see the problem? Exactly. It's not actually in the OSPF database. Or I should say, we don't have OSPF enabled on this interface. So let's go to global config mode, interface E11. I'm going to say IP OSPF1 area 0. Right? And so we should have a neighbor relationship there. We should also have, any second now, an Ldp relationship that is established between router 8 and router 5. So if I do a do show MPLS interfaces, so we've got it, Ldp is now running on Ethernet 1.1. And let me take a look at something here real quick. So now if I say do show, I guess we'll rerun that again, we'll do an end, and I want to see the sync. There we go. All right, so now the synchronization is enabled, right? The peer is reachable. It shows the peer identity of 888, and it shows the OSPF processes. So this is a best practice in MPLS environments to make sure that if Ldp, for whatever reason, has any issues, that you don't start black holing traffic by having the IGP continue to forward traffic out an interface where Ldp is having issues or is not running. All right, so now let's go ahead and we're going to take the next step toward our MPLS Layer 3 VPN, and we're going to talk about the VRFs, and then that's going to be where this video kind of stops off. In fact, I think I may cut this video off right here. So this will be a good stopping point because we've been going for a while. So what have we covered so far, right? We've talked about the label distribution protocol. Within MPLS, we've got MPLS running throughout the core here. We also looked at some important troubleshooting scenarios. We looked at what happens when the loopback addresses are not /32s. We saw that they don't have to be /32s, right? We broke it, we fixed it, we broke it again. We also looked at the a troubleshooting scenario where Ldp is not running between two routers, right? And what may the problem be if MPLS IP is configured on the interface, or the MPLS Ldp auto config is configured under the global OSPF router configuration? What problems you may run into if an access list might be put on one of the ports blocking UDP port 646. Actually, you could be blocking TCP port 646 as well, would probably cause some issues. So we now have our MPLS core. It's up, it's operational. We looked at the labels. We walked the label path between router 5 and router 9. What else did we do? So that was about it. So we've got our MPLS core configured. I'm going to go ahead and stop the video here, and I'm actually going to pick up right from this same spot. I'm going to clean the diagram up, and now we're going to go into the VRFs, And video 2 is going to be bringing up BGP for customer A. For the PE to CE routing protocol, we're going to get that configured. We're going to talk about multi-protocol IUBGP. We're going to talk about the extended communities and the different address families, the IPv4 address family, the VPN v4 address family, and we'll get everything set up. All right, I hope you enjoyed this video, and I hope to get you to watch the next video and learn a little bit more about MPLS Layer 3 VPNs. Okay, thanks for watching.